So, welcome everybody to Lecture 9, Databases and Information Systems, the course that can also be taken as information retrieval. And today it's about web applications, part 2. There are relatively few people in the room. I'm not sure why, but more people than usual on Zoom. So I will say something about your experiences with the last exercise sheet, which was web applications part 1. This should be, I think, applications. And 2 important announcements. There will be, the next lecture is in 4 weeks from now. And there's an important deadline coming up, which is before the next lecture, which is why I'm telling you about it now. And today we will just continue what we did last time, web applications. We will make them dynamic. We will talk about vulnerabilities and Unicode, important stuff. And the exercise sheet will also be to continue the last exercise sheet, make everything dynamic, secure, handle Unicode, and connect everything together. So you will also bring in the stuff we did in the first lecture, Sparkle, SQL, and so on. Just using it, but just having it all together in one system, which will be very nice, I think. Very briefly, your experiences with the last sheet. Most of you enjoyed the topic, the lecture, and the sheet very much. I think everybody, almost everybody said that. Lecture was super fun. Excited about the topic for next lecture, which is today. Extremely cool to also learn about this part of search engines. As I said, web applications is it's a major component of every information system. Even your mail program runs a web browser. Thunderbird, everything it displays, it's JavaScript, what we will learn today. First followed the lecture closely, then started to grasp how it works. So several people wrote something about how much they oriented themselves regarding the lecture, how much they did it themselves. Nice sheet, a lot to learn when solving it without the lecture. So I guess what a lot of you did was you followed the lecture and then you tried it on your own, and maybe you went back to the lecture, some more, some less, but that was of course perfectly okay. Live coding lectures are always very fun. It would be nice to have a little sheet about, I think I'm missing the sheet here, about HTML and CSS. Yeah, we were thinking about that, but that's just a very, there's just so much. I think it's easier to just Google it because there are so many things. I think this was by far the best exercise sheet so far. Forgot how much fun you can have with making web apps. Actually, several people wrote that they did web apps somehow in their youth when they were very young. You're still all young, but very young. And now you just did it again after some years and you found it to be a lot of fun. Without the video, I would have been completely lost. So a few of you already said that, but yeah, it was of course perfectly all right to follow it closer. So, some of you have done nice stuff. In the next lecture, which will be in 4 weeks, I will show demos of some of the things which you have done. So if you have done something particularly nice or put a lot of effort into it, we will see it, design, whatever, special features. So, the next lecture will take place on Tuesday, January 16th, that's 2024. That means lectures officially already start again on January 8th. There's a 2-week Christmas break. But as we said, because these lectures are typically 2 hours long and not 1.5 hours with a break, we said that we would just have 2 weeks without a lecture. We already had one such week, I think 2 weeks ago. And now we have another one, which will be the first week after the Christmas break without lecture. So the next lecture is in 4 weeks from now, just so you know. And the deadline for the sheet is also then the day of the next lecture at noon, as usual. Of course, you should start. You get a lot of inspiration and impressions from this lecture. You should at least start, I think, this week. This is highly recommended. Oh, and let me say something. There's always in the exam stuff about web applications, There's no way to get it right if you don't do it yourself. I think this is no way to just look at the slides trying to, you have to do this yourself. So yeah, you cannot do anything now and then for preparation for the exam do the sheets, but of course it would be much more meaningful to do the sheets now while everybody is doing them and while everything is fresh and you get feedback. So you need to do this, and we can just tell from experiences from exams, there are always people who make the impression like they never did it before, and then of course they don't get it right. So just do the exercises. Highly recommended. So next year there will be 3 more lectures, just as what's remaining after this, with exercise sheets, and then the typical final lecture. So on January 23rd, so this is not correct, right? Now I got something wrong. Is this correct, or is this just shifted by 1 week, Sebastian? What do you think? Now I'm slightly confused. Somehow I added a week to... Everything is shifted by 1. But does it mean that the last lecture is on February 6th? Yes, okay, I'm sorry. I shifted everything by 1, but we will just, the algorithm, I think the correct one is to do it like this. Okay, yeah, this is just 2. So what's left? So on, we have, so the last 2 lectures in the last 3 lectures in the next year will have to do with modeling things as vectors and use linear algebra. That's like a completely new topic, but very important. And yeah, I would like to spend much more time on this. We just take the time we have, 3 more lectures. And there is a space here, linear classifier, so a little bit about learning. And we will also at least start with language models. Of course, only 1 lecture, so I can only give you an intro, but better than nothing. And the last lecture, as usual, is it's no longer a lecture with a new topic, but important stuff. We will talk about the evaluation, info about the exam, and intro of how it is working in our group. So that's very important. There's a strict deadline coming up, January 14th. So this is not a deadline by us, but by the Prüfungsamt, so an official one. And unlike us, who will send you 5 reminders and stuff, and will even accept things if they come maybe a few hours or days late, the Prüfungsamt will not do that. I mean, you should do that you should know that by now. If you miss that deadline, you can't write the exam, and it's not up to us to do anything about it. And just a quick explanation, we are a very big faculty of engineering, Technische Fakultät. There's no way the Prüfungsamt can handle 1,000 requests. Oh, I missed this, I'm sorry, this reason. So that's why for a long time already these deadlines are absolutely strict. So there's a very simple consequence. If you know already now that you want to take part in the exam, register now. And certainly before Christmas. There's absolutely no reason to wait until January 14th. Because if you miss it, you can't write the exam. And there's nothing we can do about that. Okay, it's 1:15, and we start with the actual contents of the lecture. So a quick recap. So what I did, I just copied the file from last time. Here they are. So just a quick recap. What did we have? We had a server, which we wrote in Python. We had I need to get used to typing again. We had an HTML page, a very simple one with just I will show it to you in a second. And we had a style sheet, which was super simple, just look and feel. And by the way, now that I think the right way to do this, I chose the, I'm a bit confused. Search HTML, search CSS. I still, first off, type, I think is the right way to No, I don't want color red, I want color blue. This is what we were wondering about last time. If you have several paragraph symbols like we had here, I think, when we entered the result, I just want to have the first one blue. That's the way to do it. Let's also run the server. I think you should all remember this. And now if I go to this page, this is what we had, our first search engine, 6 times 7. I press the search button. Oh, by the way, this thing here, this is because the browser remembers what you previously typed. Let's maybe fix. Let's make a few fixes to get into the mood. So here I think it's autocomplete off. This is not some fancy autocompletion, but it's just the browser is showing you what you have typed previously. So now I think, yeah, you don't get this drop down anymore. You click on the search button, you get the, oh, this is still blue, even though I have first of type here. Okay, if you find out why that is, I'm a bit confused. Disable, why is the first one still blue? Okay, maybe we have to live with it, but I don't really understand why. Okay, and one more thing, let's also fix that now. This fav icon, we don't want to get this 404. This is for displaying a little icon here. Let's maybe try to fix that very quickly. If we don't succeed, we leave it. If you want a fav icon, let's just look at how Uni Freiburg does it. Let's go to the home page. Let's do F12 here. And let's see what, yeah, let's just reload again and let's look for the fav icon here. There it is. Okay, it's favicon.svg, so vector graphics. So you can provide it in several formats. So let's just copy that URL here. So if I just, yeah, so that's the icon. So it's vector graphics, which means you can scale it up as you like, and it just doesn't lose it. So let's just download this here, and this, yeah, it's just a URL. It's so now I have favicon svg, and it's I don't know. Let's maybe have a quick look at it here. Yeah, it's just XML type. It's just drawing this basically. So it's a vector graphic. Okay, let's try to include it. This is just getting warmed up. How do we have to go to our server? And I think one thing we have to do here. Also, yeah, we don't have, if we have SVG, we need the media type image SVG plus XML. This is absolutely correct. And I think we have to tell our page that we are, because it's not favicon.ico, I think we have to say that it's, yeah, and it's also not PNG, it's SVG plus XML. Yeah, so we are telling it, look, our favicon has this format. It's vector graphics, and it's scalable vector graphics, and it has this name. So let's just see how it works. Let's restart the server, and let's see if we now get rid of this. It's, oh yeah, wow, it's working. Not bad. That was faster than I was expecting. Some problems, but as you can see here, there's now this tiny icon here, and we don't get the error message anymore because we now. So yeah, once you have everything in place, it's really easy to add new stuff. And I really don't understand why this is still blue. Do you have any idea, even though it says P first of type here? And this is the first. I don't understand it. Maybe I will just revert to look. Thank you, Frank. Yeah, and then, so now I'm just doing it by ID again, anyway. Yeah, that's one way. I just give things an ID here. We will use that again also today, and now in a few minutes. Look and feel, and then by putting a hash here, I'm saying apply this color to only this item. Okay, let's go back to the slides. JavaScript. So today we will make so just 5 minutes for the fav icon and getting back into things. I think that's good. JavaScript. It's a new programming language now, and that's for code that runs inside the web browser. So now we will have code that runs inside the browser, on the machine of the person who is opening the browser, not on our machine where we have the server. And so nowadays, if you, back in the time, people would say JavaScript, it's work of the devil, I switch it off. If you switch it off nowadays, no web page will work anymore. So basically, every page contains some kind of code. You can also use JavaScript. It has become a very powerful and useful programming language on its own. You can just use it to code outside of the browser. Some universities even teach it as the first programming language you learn in the first semester. Here in Freiburg it's Python. JavaScript is also a good language for that. And that's Node.js framework for those who know it. So in principle, JavaScript is a fully featured programming language, just as powerful as any other, Turing complete. Anything you can do with computers, you can do with JavaScript. Of course, when you run it in a browser, it has to be restricted somehow. In particular, it shouldn't access stuff on your file system. A web page should not be able to remove all files on your file system or even just read them. So there are some restrictions, but you don't have those restrictions when you run it somewhere else as a normal programming language. So what it's particularly good at in a web page, you have all these elements here and you can modify them, which means you can use JavaScript to modify the page. And that's also what we will do today. And we will see in a second how that works. Just I will not give you a full introduction to JavaScript. We will just learn by example. And for the exercise sheet, you can just Google it or ChatGPT it. All things have a slightly different name as usual. Why is it called JavaScript? Well, it has absolutely nothing to do with Java. There was a mere marketing move at the time. So at the time, Java used to be popular, in case you didn't know, and in particular for web stuff. So there were these things called Java applets, little Java program running in the web browser and showing stuff. It was clear already at the time, at least to me, that Java applets wouldn't last. I don't think you have maybe a few websites with these little Java programs running in them. So they just thought, okay, we have a new web language, it should have the name Java in it. Speed is similar to Python. It's an interpreted language, so it's a script language. It's called JavaScript. Modern browsers do just-in-time compilation, which means they will compile parts of your JavaScript and then just run the compile code, and then it's much faster. Most script languages have something like this. Variables are untyped. There is TypeScript, a variant where you have types. That's similar to the type hints we have in Python. You don't have to use types in Python. We do it, but you can. Similar thing in JavaScript. We don't use it today. Yeah, and then here some example for assignments and variable types. You don't have types here. An integer, a string, an array, an associative array, a map. It's the usual stuff. If you have seen other programming language, it's like not that you have to learn completely new stuff from scratch. And we see examples today. Variable declaration, that's I think important. Why does it say let here? There are 3 types in JavaScript. The old type is var. So you could just declare a variable here. You could just write var. That was the old way of doing it. It's a terrible way. Don't do it. When you declare a variable var, even if you declare it in a function, it's available everywhere. So it's like a global variable. Just don't do it. Let, then the scope is within the code block. As usual, code block, curly brackets. And then you have const. It's when you declare a variable, assign it, and then you don't change it anymore. So these are the ones you typically use. Let and const. Var is old. It's only here for And we will just, not so much theoretical talk. Let's just start right again. So how do we do it? And I will switch between live coding and the slides. Many of the slides are just for reference. First, we have to include some JavaScript. So I just put it in the head, and this is, it's clear what it means. There's some code here, search.js, and I want to include it. And let's just do that. Now we need and let's start maybe with, okay, it's me, JavaScript. So alert, what will alert do? We will see it in a second. So now we have a new thing here. We don't even have to restart the browser. We have to, it already works. It's me, JavaScript. Alert just opens a pop-up box here, which I can then close again. Okay, it worked, even though I didn't give it the right type. Content type is text plain. So the browser is very lenient here, but let's just briefly fix that. That's also easy. I just add, if my file ends with JS, it should get the media type application JavaScript. Now I need to restart my server. Here it is. Let's just do it again. I get the same pop-up again. And if I go to JS here, it says content type JavaScript. So I'm going pretty quickly here because you have already seen that last time. And it's very easy now to add these new things. Now we are loading JavaScript. Alert boxes, like opening boxes, it's also a no-no. You shouldn't do it. And let me just, let me not even, I don't know, comment it out. No, the comment sign is like this in normal. Here's an important thing for debugging, super useful for the sheet. Console.log. So there's a console, and let's just see what's the console. You can apparently write to something. It's not the web page. Let's just see what happens. Now I don't have and here is a console item. Console, and now it's written. So it's not the console from consolation, but from the console, like here, the Linux console. So now it's just writing something here. You can use this for debugging. It also shows error messages here. Super useful, right? Don't use alert boxes. Okay, back to the slides. Now let's, so one important use of JavaScript is to modify the contents of the page. So let's just do that. And so now you have to, if you want to modify the contents of the page, you have to say, okay, this element, I want to change it. And let me just go back quickly to the HTML. So that's how the HTML looks like. And there's a thing called the document object model, which just is a scheme for how you address the elements in the web page. So one way to do it, we already used it, is to give elements from the web page an ID, result, and then in JavaScript you can address this. We already saw how we did it in CSS, these style sheets. In JavaScript you can say, okay, this element, I want to change what's inside here in our HTML. So let's just do that in our JavaScript. I will not spend too much time on the slides, but always go right into. So let's just document. Yeah, I'm getting some funny there. I have the query selector here, and let's. I don't know which piece do I want to. And let's change something right away here because I'm not using the templates anymore now. So let me just delete this. But what I will have here, I want to have a P. Yeah, why not like this with the result? And I also want to have a P with the query. Oh, this thing is suggesting funny things. Yeah, I just want to have a paragraph with a query and the result. And let me just write there now, no query yet, no result yet. Let's just do the following. Query. So I'm just selecting that element, and let's maybe do it like this so that you also see. So there's this element, it has the ID query. I'm selecting that element and I'm changing its inner HTML by no query yet. Let me do it like this, and let me do the same with the result. And let's see whether that works. So I'm loading this, then I'm doing this. Let's just see what happens. If I don't have to restart the server, I just change something here. Okay, this didn't work. Why? Do you have an idea? I will do a number of mistakes now, some deliberately, some not deliberately, because you will also encounter them. That's a typical one. It says document query selector is null. Is null means this thing here returned null, which means doesn't exist. So did I make a typo? Query here, it says query here. I can tell you I didn't make a typo. What do you think do you have any idea, or that's somebody out of it? Yeah?
Because there's no text inside the block or something like that.
Okay, there's no text inside the block. Yeah, maybe. Let's test this hypothesis. That's what live coding is for. Okay, it doesn't change anything. We have the XXX here. Any other ideas? Or maybe some of you know already. It's a, yes?
Maybe the JavaScript is executed for...
Yes, exactly. Exactly. That's an important thing to know. So let me just show you the whole thing here. This is processed in the order in which it's encountered. So that's something, so this synchronicity or asynchronicity is super important to understand in web apps. Many things happening at the same time or not at the same time, you have to understand what happens when. When this is read by the browser, it processes this line by line. At this point, it will read the JavaScript and execute it. It will execute this fairly quickly. It will print this to the console, execute these two lines, and these two lines will not find these two elements because we haven't parsed that yet. One thing you could do, there are two ways to, is async. It's not on the slides. This will now say, okay, while I'm processing, do this in parallel. I'm processing the JavaScript, and in parallel, I'm continuing parsing this page. Let's just try it. It also doesn't work because executing the JavaScript is faster. Depending on the browser, it might work. Here's another one which we will use, and I write it at the end. It's defer, and defer means wait, load it, but don't execute it before you have parsed the whole page. Defer, so just wait until the end, and this should work, but doesn't. Okay. Now I'm surprised myself. This was a not deliberate.
The hashtag is missing in the query selector.
In the query selector?
Yes.
I was wondering about that. Okay, then it's also wrong on the, so it's the like in, yeah, I think that's true. So let's do the, so my previous, yeah, it's still null now without the defer. And now let's add the defer. And now it works. Okay, no query yet is wrong. Here it should be no result yet. And yeah, so that worked now. So these little, but still my previous explanations were correct. I just wasn't proving them here. You also have to write the hash like in the CSS. Okay, is this correct on the slides? Yeah, it says this here. Okay, and one more thing, I think I want to do this a little differently. I want to have a paragraph here, and I want to write query colon, and then I want to have this thing here in a, so there's an HTML item which is span, which is just a piece of HTML, which has no particular semantic role, and I can just use span for that. It's just a piece which I want to address, maybe change its constant or whatever. So span, I think it's a good name. Just a piece of HTML which I want to have a particular name or property. So the JavaScript doesn't care what type this is, whether it's a span or a, now I should get query nothing in the beginning, and then this should change it. Let's just see how it looks like, query, no query yet, result, no result yet. So that's fine. Now we have some basic JavaScript in place and it already does something. Yeah, maybe it should say, hello, it's me. Hello. It should say hello. Let's go back to the slides. So, okay, yeah. Let's do that right away. We should, I mean, that's of course something we want now. That's one very typical applications. The user does something, for example, typing, and with the typing, you want to do something. And there's also, here's the JavaScript way to do it. You have a query selector on an input field. Let's give it the ID input. I will do that in a second. And then add an event listener. I mean, it's self-explanatory. Just wait for something to happen. And here in a string, you say what it is that you want to happen. I mean, there's of course a whole world of events and things, but this is what we need here. Input says something changed, some user action in the input field. So let's just do that. Let's go back here. Let's give this thing a name. So this is our input. I mean, it's the query, but we already have ID query here. So let's do that. So let's, so this is input here, and I want an event listener, right? Yeah, I want to add an event listener. Yeah, I don't want key up. So you see it suggests key up here. Key up is, there's key up, key down, key pressed, input. There are subtle differences. And now an event listener, that's an important concept of, now I want to say, okay, when something happens in the field, do something, and that do something I want to specify in a function. So now I need the second argument is a function here. And one thing you see a lot in JavaScript is anonymous functions. So what's called lambdas in other programming languages. It's just a function, and I can just define it on the spot here. I don't really care about the arguments. This is just, okay, execute this unnamed function without arguments, and now it should just do something. And what should it do? Well, let's first read the query from the input field. Let's just see what's in there, and that's, yeah, let's just read the value from the input field, right? Let's just do that, and let's log it to the console. So now what we are doing is, whenever something happens in the input field, let's just read what's in there and show it. And now you have another typical thing which you don't see in other programming languages, this funny combination of a closing curly brace and closing parenthesis. This closing curly brace is the opening curly brace from the anonymous function, and this here is from the function where this was an argument. So this is a very typical thing, curly brace, closing normal parenthesis, semicolon, and you just write it like this. Let's see whether this works. We don't have to restart the server. Let's see if I type something here. Yeah, it works. So I'm typing something and it's telling me, so we are already one step further, right? I have some user. So you see it's very quickly. It's a great thing about JavaScript. You can do very powerful thing. I mean, that's not super powerful, but it's something very quickly with few lines of code. Okay, so what do we want to do next? Okay, this we already, yeah, by the way, since it's on the slides, there is the typical way. What I did here is you said JavaScript code, load that file, execute the code from there. You can also use the script tag to write code directly in the HTML, but it's always nice. This is the modern way, I mean, the way you should do it. Here I have my style sheet. I have it in a separate file. You could have everything in the HTML directly, but we don't do that. The defer we already talked about. So now what do we want to do next? It's obvious, I think. We don't want this stupid search button. We want things to happen automatically. I type something, and immediately when I type, the action should take place which so far took place when I clicked search. Just recall how we did that. We had this funny form thing here, which is also from the 90s. You don't see that a lot anymore. And I don't want that anymore. Now I want my JavaScript to do this. Whenever something happens in the input field, send something to my server, ask for the result, and then put it in place. So I don't have to reload the page or anything. I just work with the page dynamically. So how do we do that? And let's just, it's on the slides, but maybe let's first do it, and then I explain it. Because now talking to other machines is a lot of things. It's also not hard in the code, but a lot of things to understand and get right or get wrong. So let me, so I want a response, and now it already suggests fetch here. So now, how did we do that so far? So far we had this search HTML with a query parameter, right? So fetch is talk to this other machine, and I think this is how we did it. Search HTML query. This probably is still, it doesn't work anymore because I removed the percentage result, but I think I can still send something. Let's see, via the network tab, yeah. So now I said, that's how we did it last time. We appended something to the URL, question mark query 6 times 7. And here, what I get back is a whole page, right? With and the only reason that it doesn't show here is because I removed the percent result. Actually, I could just probably insert it again. This is how we did it last time. Result, I think it was called. Let's just revert to that for a second. Yeah. We just had this template mechanism, right? It just replaced it. So let's just use that for the JavaScript also. This is now calling the server with this request. And now I need to do something which I will explain in the slide in a second. Now I want to say then. Then means this is something, oh, my voice is, let me take a second and read what's on the chat. Yes, the thing's missing. So there's a question in the chat. Let me briefly respond to that. What's the difference between having this here in the head or in the body? And the answer is, it just happens where you put it. And typically you want the code to be executed before everything else. So that's the main reason for doing it in the head. Could also put it first thing in the body, but it's just more logical to. Wherever you put this, it happens unless you put a word like defer. But the loading happens. I don't think there are any safety issues. You just have to be aware when it's executed. Okay, then this gets back a raw response here. Actually, I think we can. Here's another thing, and I will just let me do it like this. First, fetch is something which happens asynchronously, right? It's something you have to get back a resource from somewhere else. This is asking the server, and the server could take 10 seconds, 5 minutes, 5 hours to process this. So this is something which takes time, and it's kind of happening outside of the browser. So await, we have to wait for it, and await is an important keyword here. And let's just look at, let's just output this response here and see what's happening. Let's just see what's happening. And now I have to, I think, go back to the original page. And I think I will remove the template thing here again. I don't need it. It was just for, I'm sorry. I'm sorry. This was back here. Bam, bam. So now let's type something. Let's maybe go to the console and see what await is only valid in async functions. Aha, I will explain that in a minute. For now, let's just follow the... So here it says await, and if there's await, this has to be async, because this is now a function which does asynchronous stuff, right? It's sending fetch, it's waiting for the fetch. Let me put that in a new line here, so that I don't overflow. Okay, you have to, maybe I explain it right now. This could take a long time, right? As I just explained. So, of course, you don't want your whole web page or the JavaScript to be as unresponsive, right? That's why you write async here. Async means while this is running and not doing anything, like waiting for the result of this fetch, you can do other stuff. And I will have it on the slides in a second. But let's first do it hands-on. Let's see what happens now. Okay. Now okay, I have to type something here. 6. Okay. And now I see I get a response object here. So it did something, it talked to the server, it sent this here. So actually it works, right? When I'm getting all these requests here on the server side when I'm typing something, and I'm getting stuff back. And the stuff I'm getting back is like a complex object here. It's even showing me the whole object here. It has a body and all kinds of header information from the HTML. So a bit too much information. What I really just want is what the server sent to me. So let's just get that. And the way to get that is I just want the result. And and the result was actually HTML, so I can just get the HTML from this. And this is also something which might take time, so I'm doing it asynchronously. So let me just log the result here. Yeah, so first I'm getting something, a raw response, and now from that raw response I just want the HTML. And let's just do that and see what happens. I'm typing 6 here. And now I'm response.html is not a function, okay? I think I have to choose text here. I think what's important is the first thing of the media type. It's text, and it doesn't interpret it in any way. You can talk about that more if you like. 6. Okay. So what happens now? Try to understand this. Why do I get... I type 6 times 7 here. I don't get 42, but I get this. Why do I get this? I want 42, right? When I type 6 times 7, but I get the whole HTML page. Just try to understand why you are getting this. This is the JavaScript doing this. So this code is giving me the whole web page in return. Why? Yeah?
That's just how we did it. We always completely send a new page and just replace the results.
Yeah. That's exactly right. That's how we did it so far, right? We are asking for, we are doing it even here, search HTML, query. Our server gets this request, and what it did so far is returning a whole new web page with the result. That's how we did it so far. That's how it was done in the 90s. And now we don't want to do that anymore. So let's go to our server. Let's go. Yeah, we are always switching back and forth between the individual components. That's what we did here. I think I need to make this a little larger so that it's, where did we do this? Here, right? If the request is searched HTML, then we compute the result and then do this, replace this template here and return the whole HTML. Okay, now we don't want the whole page, we just want to ask a query. And one way to do this, then we shouldn't ask for, now how do we ask this request? Let me do this like this. I mean, we need to have some name here, and a typical name here is to call this API, because I'm just making a request to the server. API is a interface, the I stands for interface. Is API, what's actually the full abbreviation? Is it a programming interface, or actually what does API stand for? It's application programming interface, yeah. So that's why we're just talking to the server. And we could choose any name we want here. Let's just call it API query, and now let's handle that in our server. So if the path is API, the passing of the query we did already here, right? This doesn't change. If we have query, just strip it away and parse it. So we already have that in the query variable. If the request is API, then do the following. And let me just make a string out of this here so that I have a string either way. No, I don't really need this thing here. I don't need to produce. Now I have a string with either result or invalid expression if it's not yet an expression. And now I just send, I guess I just send that back, right? Let me just, and here its result is nothing. I mean, I shouldn't call API called without query. Okay, should not happen. And then now my response is just this result. That's just what I send back. Let's just see what happens. I'm just sending that back now. Just either the result or the... Yeah, let's just see what happens. Now I changed the server, so I have to restart it. Let's just see what happens now. Let me type 6. And now I just get result 6. Okay, let's look at it in here. I see my API call here, 6. Now that's what I sent, API query equals 6. But it's really just a string I send, right? And I'm following just some conventions here. And for some reason it says 404. Why does it say 404? That's something in my, I mean, it worked, but it still sends a 404. What did I do wrong in my server? Oh, I understand, because we first try to read this as a file. The file API does not exist. Then it sends not found 404, and then it does this thing, which actually does the right thing. So now, and we had to do it in that order, because before we read the search HTML file, then we processed the query, changed it in the HTML file, and sent that back. Now we don't do that anymore, so we can just do this before this. Okay, if, and now we should also change this. So if for an API call, just evaluate the query and compute the result. Let's compute the result. Bam. Okay, and then this should only happen otherwise. So let's just put an else here. This should work, and let's just indent this here by 4. Yeah, so either the call is API, then I do this, then my response is just whatever I computed. Here it's just a simple expression. Otherwise, this should now be otherwise interpret the request as a file name. Read the file and return its contents. Yeah. So our server is now different things, right? It's either computing stuff when I call it with API something, or it's just serving files. There was a question, or any question? Did I miss something? There's a question in the chat. More than one script with defer, in which order would they be executed? Okay, that's a good question. If I would have another script here with defer, yeah, I strongly assume that they would be executed in the order in which they are encountered, right? So if I have search 1, search 2, search 3 here, they would be executed in the order 1, 2, 3, but only after the page is loaded. So let's try that here. See if it works. Okay, now type something here, 6. Okay, now I don't get a 404. It's not changing here, I'm just outputting it here so far in the console. Okay, now maybe let's go to the slides back a little bit, because no, I don't want to go to the slides back just yet. I will explain it in a second. Let's do a little bit more coding. Now we just send this as, let's see how we send this. Let's go to the network tab and go here. And what are the headers? Alles supi, content type text plain. So I just send it back as text, my result, the 6 or the whatever. If it's here 6 point, yeah, how do I think I have to make it a little bit larger here. Yeah, now I see now the request was, where's my 6 times 7 was the query, and I get the reply here. What's the response? It's 42. I'm sorry. And it's just content type is text plain. Typically the answer is something more complex, and what you want to return is actually a JavaScript object, something which you can process directly in your JavaScript, and that's what we will do now. And let's just see. You don't want to return text, which then your JavaScript has to parse or something like that. So let me just do the following here. I want to write, and let me use, we are in Python, so let me use, yeah, that's not bad. I want a query with a query and the result with a result, yeah. Let me maybe quickly explain that here, what I'm doing here. Okay, I have to close the string here and do this. Here I'm just constructing a string in case you're wondering. Yeah. So I'm just using a formatted string here. I want to use curly braces. The curly braces have a special meaning in a formatted string, right? It's what it's saying is evaluate this here. That's using the variable query and putting its content. That's what the meaning of curly braces. If you have a formatted string here, f, and if I really want the curly brace, I have to write it twice. So that's just escaping the curly brace. So now I should get in curly braces query, colon, the query, in quotes. I also have to escape the quotes, and result, and this is the result I computed. Let's just do that, and I have to restart the server because I changed something in my server. Let's go back to the browser, see what's happening on the console, 6. Now I'm getting back this. This is what I just did here. Oh, and why do I have 2 things here? Probably because I made a mistake. Oh yeah, I forgot the F here. Oh yeah, that's also why it's put, right? I forgot in the second part, I forgot the F, so it's just taking this verbatim and not plugging it in. So I have to restart my server again. You see, nothing conceptually hard, but it's just a combination of these many things. So now I get query 6, result 6. This is already looking very good, right? 6 times invalid expression, 6 times 7, the query is 6 times 7, the result is 42. So now I'm sending a result which is already a valid JavaScript variable, which is very convenient in my, and let's just make use of that in my JavaScript. So now this is my, and actually I don't have to, let's just, so now I can read the result. The result is now just my, it's saying, yeah, this is kind of the result. Why do I call it JSON? I think I will say that in a, this thing which I'm sending, JavaScript object, JSON is JavaScript object, it's on the, and what does the N stand for? Notation maybe? What does the N stand for in JSON? So that's a abbreviation, I think it's JavaScript object N. You can look it up and tell me. So this is now a JavaScript object, and I can just say it has a result part and a query part, and I actually don't need I already had the query above. And now let's just plug that into our web page. So I have these document query selector query and result. Now I'm just reading this out of what the server sent me. Yeah, let's just see whether this works. Let's just see what's happening. 6 times 7. Okay, this works. Result is undefined, so somehow it's not reading the result. I also wanted to put the result here. Let's check that. Why is that not happening? Probably because... Line 11? In line 9, what did I do wrong? Oh, okay, that's true. But where's the error message which is complaining about this? Yeah, that's a bit mean. Right now I'm sending this as a JavaScript object, and now I have to say this is a JavaScript object. Actually, there are two. Yeah. So first I should say here, interpret this as a JavaScript object, and I will explain it once more on the slides in a second. Let's see if this alone already works. Okay, oh yeah, now it's also showing it as an object here, right? Do you see the difference? Let me just do that again. That's, I think, very useful. If I do text here, it's just interpreting it as text. I mean, it looks like a JavaScript object, but it's just printing it as text. And then if I say, give me the result part of this text, it doesn't work because it's just a string. If I say JSON here, it's interpreting it as a JavaScript object and also showing it in the console as a JavaScript object here, which has two parts, a query and a result. And then indeed I can write something like, give me the result part here, and put it there. Okay. And it didn't complain, although it should have, that I'm not, let's just look at that in the network tab here. I was returning it as text plain, not as JSON. I don't know why the browser is not complaining, but let's just fix that. So if I'm, no, this is not something I should do here. I should do it up here, right? Here I should fix the media type. It should be called application JSON because I'm sending something in JSON. I have to restart my server now because and let's look at that now. 6 times 7. Let's look here now. Now it says application JSON, how it should be. In the console it's a JSON object. I'm putting the query here, the result here, and it works. Okay, so now I have a working, okay, invalid expression. Oh, there's one more thing now. What's the %20 doing here? You also see it here. 6 times 7. It doesn't work, invalid expression. That's what my server gets. What's the problem here? Yeah, it's the decoding of space. Now it's doing something else. The form sent the space as a plus. Now it's decoding the space as a percentage 20. If I do ASCII here, or maybe I should go to let's look at the ASCII table. 20 is the space, right? In hex, %20 is the space. So let's just fix that in our code. I think we had some very basic escaping here. It was up here. Now we don't, it's not the plus, but %20 should be replaced by space. Let's just rerun the server. And let's 6 space times 7. Now it works. Okay, now I can, now I can compute. Yeah, it's quite impressive, right? I have already a working web app here. Not bad. So it's just working. It's search as you type functionality. It's really quite good. And now, when you get that in place, now it's easy to also do more complex stuff. So pretty neat. Now let's go through the rest of the slides, just recap some stuff, and then let's have a break. Is there, would you mind sharing your, if we had more, okay, that's something. So yeah, let's do that before the break and then have a break. Just recap some things, the fetch here. So yeah, this is how we wrote it, right? We had this fetch. We didn't use then. Let's maybe do that very quickly. It's just an equivalent way of doing what we just did, because that's a very so here I'm waiting for the return of the call. I get the raw response object, then I want the JSON from that, and here I have 2 steps, and you can just write them as one. And let me maybe just comment that out, and let me write it how one would usually write it. So you have a fetch, and when that is done, do something. And now and now here's another thing. This funny notation, I will explain it on a slide. What does this mean? I mean, what I want to do, I want to take the response and do this with it. It's what I did here. And then this should be my result JSON now. So I don't need this intermediate object. Result JSON. And let's explain that on a slide. And I think this I will explain after the break, the async and the wait, but let's maybe first, this I will explain after the break, and let's maybe this one here. That's just, so that's what I just did. I did a fetch, and if this fetch, if the answer comes, then what's in the then will be executed, which is a function, and that's something you have a lot. I already said that, anonymous function. So it's a function which gets the response from the fetch and does something with it, and it does something very simple. It just gets the JSON from the response. I don't want all the other HTML, HTTP, not HTML, HTTP information. That's a very typical kind of anonymous function. Gets an argument, does something very simple with it, because that's so frequent, you have a shortcut for it. This is, the bold thing here is exactly the same as this here. Take this as an argument, do this. It's exactly this. It's just a shortcut. So if you wonder about this in JavaScript code, it's just an anonymous function shortcut. Also works for multiple arguments. I will explain the rest in a second. So that's the way how you will typically write it in JavaScript. You fetch something, and then you say, okay, I want the JSON from this, and then you assign it here. Let's just check whether this works still. No, because I did something wrong. Note how nice it is that you get this debug info here. It says in line 11, it's a scripting language. I did something wrong. And of course the semicolon here doesn't work. So it is complicated, all those things together. But okay, now it's time for a break. A few more explanations on this and then on to the next part. 5-minute break. So on to the second part. So we have a working JavaScript web app now. And that, of course, will be the first part of exercise sheet 9, is to make your web app from the last sheet dynamic. In that way, as usual, you can just follow what I did in the lecture. Maybe you want to do more yourself or follow closer the lecture. And you have a lot of instructions, explicit instructions here, how you do it. I want to explain a few more things. I mean, you don't really need to understand it, but it's of course good to understand it. I mean, you should understand it, but to do it, you can just, let me start that sentence again. It's about this await, fetch, then thing, right? There's always 2 levels of understanding. One is, okay, you just have to write this and then it works. But there's actually some stuff which is interesting to understand here, and I want to briefly explain it. Let's spend a few minutes. Why is there async here? Why is there await here? What is this then here? I already explained the syntax. This is interesting, so please listen for a few minutes. And here's some, and it's actually, it's really interesting. So here's the first thing to understand. Pay attention because it's really interesting and important. JavaScript is single-threaded. This is quite surprising because many things are happening at the same time, right? Here something is loaded, here something is blinking, an image is still being loaded. It looks like it should be multi-threaded, right? Many things happening at the same time on a web page. We said you can write async in the HTML, and then the page is loaded while JavaScript code is executed. But JavaScript itself is single-threaded. And what does it mean? At every point in time, let's just go, here's JavaScript. This might be very big code for a big website. At any given time, you're at exactly one point here. It's not different strands of execution, right? But still, you have asynchronous functions. And the most typical asynchronous function is like fetch, get something from another server, like we did here. It was something very simple here, but it could be the result of a big computation. And you can declare functions async. And the important part to understand here, that if you call such a function, like fetch, then this is time which is not spent in the normal JavaScript, it's spent elsewhere, right? I'm now asking the server, now a server on another machine is doing something which might take a long time, and there's no JavaScript happening in the meantime. It would of course be completely wrong to now wait for this, right? And do nothing, like have really wait here. Like the JavaScript at this point, it stops, it freezes, and then the server takes 1 minute. In the meantime, you can't do anything with the web page. So what you want is that in the time while something is happening outside, you can continue with your JavaScript. And that's what JavaScript is doing, right? So JavaScript, when you write this here, await, then it will say, okay, let me just wait for this. In the meantime, carry on with some other part of the JavaScript. Maybe you added 5 different event listeners here, and some other event is happening and something to do there. It will just continue there, right? So what JavaScript has is kind of a stack of things it has to do. And whenever it has to wait for something, then it says, okay, let me put this on hold and continue here. It will only do one thing at a time, but it can jump between functions. So that's important to understand. So it's single-threaded, but it can jump between different frames of things. And then, and the nice thing here by writing the syntax, this I'm not explaining here, the old way of doing this is that you would have callbacks, right? You would have say, okay, fetch this, and when this is done, please call a particular function in my code, and then this code is executed. You don't have to care about this here. It will happen automatically, right? The await will say, okay, while I'm still waiting, do something else, whatever you have to do, and as soon as I'm done, I will continue execution here. It enables much nicer code. But you do have to understand what's happening, and it can be really tricky because, yeah, the JavaScript code jumps between different things here. So that's one important thing to understand. Single-threaded, but it can jump between frames. And now these are the keywords which are important: async, await, then, if you don't want to use callback. So this means this is a function which might spend time elsewhere and just wait. So you must declare it async. We got an error if this was not async. Await means, yeah, I just explained it, wait and do other stuff in the meantime if you want, or do nothing in the meantime. And then also belongs to this. I also explained it, and there was a question in the chat. Maybe I explain it again here. This fetch is something which can take time, and this means wait for the fetch, and this is how I wrote it here, right? Do an await on the fetch. If it takes time, do something else in the meantime. As soon as it's done, then execute this next function here, right? And wait for that too. And you can have a whole chain of this here. I could have another then and another then and so on, right? Which each then awaits the reply from the previous, whatever it is. And this final await then just awaits here the final then. So this await really is an await for the final then, however many thens you have there. Yeah, and all three of these are used here, and you also need them for the exercise sheet, of course. And yeah. And this is one thing now, that's one level below, but let me briefly explain it at least. How is this done in the JavaScript code? It's actually, you could code this yourself. It's done using promises, and you could even look at that, but we don't have time for it now. What this fetch does, it actually returns immediately. You could just write it in your code and look at the object, and what it returns is an object called a promise. And a promise has, it's just an object which has two components. One component is that it said, okay, what's this current status of this thing, right? The fetch returns immediately, and and then I could look at the object and it would tell me, okay, something's still ongoing here, this has finished, this has failed. So these are these three things, and I can ask that object repeatedly if I want, and the result if it's fulfilled. So let me say that again. You could, instead of writing await here, I could just have a normal assignment, let some variable equals the result of the fetch. I will get a result immediately, and now I can look at that result now or in 10 seconds or in the future, and I can always ask that result, okay, what's the status of this operation? And it will tell me ongoing, finished, failed, and if it succeeded, what's the result? And it's a lot of fun, so if you have time or you are interested, play around with this by just looking at the objects. In the JavaScript, output them, right? You can also write promises yourself. If you write library stuff, you would do that, but typically you don't need it because you have nice functions like fetch, which hide all this from you. And whenever you have a promise, then you can use these, if you're using this async, await, and then. I think that's enough for now, because there's other stuff I want to show you. JSON I already showed you. One last thing, just to mention it, you don't need it for the exercise sheet 9. This thing here, this is now very fast, right? It's sending a lot of requests. Just imagine each request here would take seconds or minutes. And it will be so for exercise sheet 9, because each request you send requires computation on the part of the server. Here it's very fast, but imagine it takes time. then the server has a lot of requests it has to handle at the same time. So it's very natural for the server to be multi-threaded. Every reasonable server which processes stuff coming in from one side or from many sides at the same time will want to be multi-threaded, right? So a typical server, what it would do, and it would actually be very easy to do in our code. Let's just go to the Python code one more time here. What does it do? Let's go back to the socket communication. I received the request, and now I call handle request, do the actual work. It would be very easy here, even in Python, to just say, do this in an own thread, right? Open an own thread or even an own process, handle that request there, and wait for the next request to come in. Because of course I want to be responsive. Yes, please?
Isn't it impossible in Python to have multiple requests?
Impossible or possible?
Impossible. I mean, you have to launch a new stuff.
Yeah, exactly. That's the next thing. Actually, you could write it here, but I don't do it now. You could say, do this in a new thread. It would work, but then it wouldn't, because Python is terrible. I mean, that's the reply to you, to what you just said, at multi-threading. Because Python has a similar problem or feature as JavaScript, that it can only execute one piece of Python code at a time, because Python is an interpreted language, and this interpreter has a lock. So you can't have two threads and they execute different parts. One thread is executing this and another one is executing this, because the interpreter is not multi-threaded. It has state and so on. So there is a module in Python called multiprocessing, but that will copy the whole process, fork as you say, and then you have two processes, full processes with a complete data. And for the exercise sheet, the complete data would mean your complete qgram index. So what it could, I mean, we tried that in a year, I think last year or 2 years ago. You could say, okay, this response, now just copy the whole process, and then it will take time and a lot of memory. It will copy the whole qgram index and everything for responding to your queries, and now you have a copy of the data structure. And if you have 5 queries at the same time, you have 5 copies and you will just run out of RAM. So bottom line, Python is terrible at multi-threading. And it's just really terrible. There's no way to solve it because the language is just not made for that, which means a reasonable server will have to do this somewhere else. So what we did do, or Sebastian did instead, that's why we had Rust code. To speed up for the exercise sheet, you want fuzzy search, and if each query would take like half a second, then you would run into a situation that your web page would become really unresponsive, because the requests would just pile up and then it would be terrible. Okay. Now we have to go to the next topic. We have 2 more topics, 15 minutes each. They're very nice and interesting, but smaller topics, but interesting to know. Now we just, without much care, we just did something here and we were happy when it works. But now there are some potential problems which maybe you didn't even think about, or maybe you did. And let's look at 3 of them. Access to private data, code injection, and let's just see what it is. And this is just for reference. Let me mainly show it here and then go back to the slides occasionally. What is one thing we could do? Yeah, let me do proc CPU info here. Okay. So what did I do? I mean, of course, I wrote this so that I can show my nice search, our great search HTML page, but now I just wrote /proc CPU info, which is a file on my machine, which lives somewhere completely else on my machine. Here it says get request for /proc CPU info, and it's just returning the file faithfully as I programmed it to do. So that's now the CPU info, maybe not so private on my machine, but maybe not something which I wanted to share. And I weren't even aware that I'm enabling this. This machine has, actually it's a big machine with a lot of data in it. I've now written an application given to the outside world where you can read any file on my machine. Maybe not what I want. Maybe my mail is on there. Yes?
In the last exercise sheet, we were instructed to also handle traversing of the tree.
Yes.
For some reason, I didn't get it to work. So the browser and even curl refused to interpret this double dot. Is this something new or?
Yeah, that's a good point. So browsers, because users or even application programmers forget this stuff, browsers also try to say, this looks fishy, maybe I shouldn't even let this through. I mean, now, of course, I don't know how you programmed your server. Maybe for some reason it doesn't let this through. Actually, I don't know what happens here when I type ... Okay.
It just disappears for me as well.
Yeah, it disappears. There's some protection built into browsers, because browsers, sometimes they say, okay, this is never right. I will just not accept it. But as you saw here, this worked, right? So I can certainly access via the full path name file on our system. And that's not something I want. Of course, it's easy to solve. Let's just go back to the path. I'm not showing this now. This would also work. 888. Here we have 8. I should maybe fix that. Of course, once you're aware of this, these are usually very easy to fix, right? How do you fix it? You say, okay, this thing shouldn't contain slashes, or the really conservative way is just have a whitelist. This server is only for these files, or only for these files in this directory, or something from this. Otherwise, that's why you have forbidden or something like this. So that's easy to fix. Code injection, that's another fun one. Let's look at it. We have a working web app. So let's just go back to search HTML. And let's just, let's have fun and write some, let's, devil.com. Click me. Okay. Yeah, I mean, if you think about it, it's not surprising. I wrote a piece of HTML here, and what is my JavaScript doing? It's just changing this to this. Let's just click on here. I'm repeating this joke as long as I'm still amazed. Every year we have this joke for a number of years now. devil.com just redirects to mybible.com. So the Catholic Church, for some reason, bought this domain. It's really funny. Yeah, it's for a number of years now and doesn't change. So, now you can say, okay, that's not really harmful. I'm just inserting a link here, but you could imagine scenarios where this is harmful. And maybe let's. I like to put because we will talk about HTML. Let me also put what's the HTML entity or the devil in Unicode? I think there's a symbol for the smiling face with horns. Oh, it's a +1F. Yeah, we will talk about that in a second. That's why let me try that as an HTML entity. Let's have a little bit of fun here. Let me try that. Add hash semicolon. Ah, no, that's not the. How do you put an HTML entity with a. Who knows that? I thought it was hash, but apparently it's not. We'll come back to that in a second, but now I want to, no, I don't want the winking face. How do you, if you know the Unicode code, how do you specify the HTML entity? Does anybody know? Apparently it's not hash, the code, but it's smiling face with horns. That's the political correct way to say devil. Okay. Smiling face with horns. UTF-8. Code points. Here it should say what I want. Oh, it's hash. No, it does say HTML entity. Oh, X, because I did it in, I think. Yeah, now I have it. Okay, the X was missing because I specified it in hex. Okay, now I have that one. Okay, so you can insert arbitrary HTML if you don't pay attention. Happens pretty quickly. So yeah, that was just a click me hack, of course. Or just think of this, in your GET request here, you just insert JavaScript, you can execute arbitrary code. It's maybe a bit more dangerous already. And now you say, yeah, well, I will see that if there's a script tag in the URL, but there's URL decoding. We will talk more about it in a second. You can just obfuscate this, right? So if you get links with a lot of funny characters like this, be aware that maybe you should look at it more closely. Okay. Here's another one. Yeah, okay. On the forum, of course, the forum has to take care of this too. On our forum, if you post something like this, and then you, if the forum software wouldn't pay attention and you just have a script in there with JavaScript code, and early versions of such software did this, it would just execute the code. And now this is code running on your machine, and it could do stuff with your data, right? So it could like, even maybe you have Gmail open or some private data open in another tab. It could just steal that, send an email. Yeah, it could. It's quite easy actually. If you are into this, you can try it yourself. I mean, this is now running here in this is now running your code, and you can do all kinds of stuff. If you manage to grab personal information here, then I can just send a fetch request to this server here with the information, and now my server has that information. And that's, of course, still an ongoing topic. Here's another one, same origin policy. Let me also show you by an example. It's, I think, the best way to understand. So here, so far, all of this was happening on one machine, but it doesn't have to. Let's ask the same thing here on a different machine. I mean, I could have specified, so the machine we are working on is called Tura. That's a river in Asia, Russia, I think. So this should also work. It's Tura 8080. I'm in a local network, which means I don't need fully qualified names. Let's just try that out, whether it works. Yes, this also works. And so this also works. And it gets the request here. So let's just check. The machine is Tura. We also have another machine, which is called Amur. This is another river in Asia. Our machines currently have river names. So let's, no, I don't want to go to, I think I want to go to teaching information retrieval 24, public code lecture 9. Yeah, that's our code. Now I can write, actually, think about it, it's kind of funny. I can run the exact same server here. No, let me first not run it and see what's happening. Let me now just ask another machine. And now I should get 404, right? Because nothing is running there yet. Let's just do that. That's fine. I didn't send anything. 6. Okay. It's not even sending the request because now it's saying, okay, this is not allowed. And I will explain in a second why it's not allowed, but let's first see that it's not allowed. So now this website is running, it's talking to a machine called Tura. And now the JavaScript wants to talk to a machine called Amur. And it's not allowed, even if I'm running this here. So it doesn't even reach the server, right? Yeah, no request here. Because right away when I... Oh, no, it's not true. It's not true. Okay, I have to, the last sentence is not true. It reached the server, so I'm getting this request here on Armour now, 6 times 7, it's even computing something, but the JavaScript says I'm not allowed to use this result. So this page now wants to do something with the result, build it into the page, like display 42 here, which this computed, it says I won't. And let's first see how to fix it and then explain why it's a problem. The way to fix it is, in my server, I could, and let's just quickly do that. Here I add another header and I'm saying if, and I think I only need that for the RP call, if, what was the, if request is API. Yeah, let's do that. If request is API, that's correct. I add an access control header. And I want to say, so I'm the server now. This will be running on Armour, on the new machine, on the second machine. And I'm saying, now I have to, so which one? Now who has allow what to whom? Let me think about it. Or let's think about it together. Well, what's the security situation here? So I'm thinking about, does Tura have to say, yeah, it's okay to use the result from Armour, or does Armour have to say, it's okay if Tura uses my result? Which of the two is it? Now I'm slightly confused myself. I mean, I know it, but I'm just, what's the security situation here? This allows reading the So what do you think? Which we could, of course, just try it out, yeah?
If it disallows the reading of the answer, then we should allow to read the result from, on the Tura server, we have to specify that we will allow reading the result. Would be my guess.
Okay, let's verify that, which means I don't have to restart this server. This is Armour, which is just, we now use Armour just for computing the results. But here we are saying, let's do that. I have to say on Tura, HTTP, Armour, it's okay to read results from Armour. And I have to specify the machine and port. Let's just do that. Let's see if it works. So now I'm restarting Tura, this one, and let's just see if it works. If that resolves the situation. Okay. The same. Now, of course, the question is, did it? That's certainly some, yeah, I always, is the header here? I mean, first of all, let's verify that if request equal API, first I should see the header here, right? Access control. Sorry for the confusion, but it is confusing. Cache control. No, I mean, it has to be for, I mean, this is not responding to a request now, right? So I have to, it has to be Armour which is sending this header because it's computing the reply. So let me restart the server on Armour, and this should not change anything, but at least I should see the header now, right? And then let's, where is the, yeah, it says here, access control allow origin armor. Okay. Now armor is saying it's okay if armor uses my result, but I have to write, I guess I have to write Tura here. Okay, let's just do it the stupid way right now and then try to understand why. So let's write Tura here and restart the thing on armor. But this is something, and now let's see whether it works. 6 times 7. Now it works. Okay. So armor, but it's actually okay. It's confusing and you have to ask exactly the question which I just asked. Who has to allow whom something? So this worked. So let's just see what we did. And then let's try to understand it, or maybe not fully understand it. You have to do that at home, but just what it's about. So what I now did, that armor with its result sent a header, and we can look at that header thanks to the development control here. It said access control allow origin. It's okay if Tura uses my result. This is what we did, right? Armor, the machine, the new machine, which does only the computing now, not file serving, says it's okay if Tura uses my result, and that way my web page works again. And by the way, we could have just written star here, which means everybody can use my result. And why is that important? Well, a typical way, just assume Comdirect, that's just an online bank, and actually it's not Comdirect, it's Comdirect with a C, right? So that's a wrong name. Now you just build Comdirect with a K, people will not notice, and you make it look like exactly the real page, yeah? For some reason you happen to be good at this, make it exactly look like a real page, and now people enter their data, they log in, and now you just send that data to the real. You know how the API calls to the real page work, and they will have a different domain. They will have Comdirect with C, right? And now Comdirect with C, the real bank, will not allow Comdirect with a K, the wrong one, the evil one, to use their result, right? So that's why what we just did was the right thing. So the one providing the service could be confidential information or private information. It has to be careful, who is allowed to use my result. So here we are just computing mathematical expressions, so we might just say everybody who calls me can use my result. But if you are a bank, if you are the server, you are giving out secret information, you should be careful who may use your result, and you will restrict that. And actually if you, I don't want to advertise for banks here, it's just something that came to my mind. I think if you do this, if you enter this into the browser, it will actually redirect to the real bank, right? Because they bought these domains as well too. So that's a typical way. And actually there's even laws that you are not allowed to put up websites with very similar names, right? So like Google or something, that will probably also redirect, I don't know. Let's just try it, because otherwise you could do all kinds of, So basically these companies bought all the domains which sound similar. And if you buy it or bought it before, actually you can be forced to give it to the company. You can't say, I bought it, now I will use it. And it just differs by some tiny character. Okay. So that's just explained here on the slide. I will not go through the slides anymore because I already explained it. And there's one exception to this same origin thing. So it's easy if everything is happening on one machine, and that's JavaScript. So JavaScript, so in the past we used jQuery. We don't use it anymore, but maybe you want to use libraries. Here we're using JavaScript from our own machine, but maybe you want to use a library which provides all sorts of fancy functionality, and you can use that. So you don't need anything special for that. You can just write this. And there's a little story here which I think I will just skip and rather talk about the last part. So in the past this was exploited for all kinds of things. And let me just skip to the last part. Yes, and that's correct what you wrote on the chat. Last part, and then we are done. That's actually nice and easy, but it's something to, we have already seen the encoding stuff. It's 13 slides, but don't be afraid because it's not deep and also not much live here. So context switch, it's something, it's not completely new, but you don't need what we did so far. It's just about how do you represent all the funny characters in the world, right? So we have seen the little devil here. It's no longer here. No, I don't want the, yeah. So we have already seen Unicode here. You have, of course, the letters, but you also have funny characters in other languages or even symbols. How do you represent those? This is what Unicode is about. So a little bit of history. So for the longest time, the standard was ASCII. And we saw the ASCII table here. That's the ASCII table. It's what can you represent with 1 byte. And it's actually just showing the lower part until 127, so that's 7 bits from 0 to 127. And what you see here is all the typical characters, right, in Latin script. Of course, a strong bias towards our script. That's just how it is historically. All these typical characters here, the small Latin letters, the capital ones, and some symbols. So, of course, that's not enough, right? 256 in 1 byte. Chinese alone has tens of thousands of different symbols. So many other languages. So how was it done in old times? In old times, you would use the lower part of ASCII, what you see here, for the typical characters, which you use in programming and computer stuff. And for the other part, you would have different standards. So one standard, which is still in use today, it's called ISO 88591. If you now look at the bits from the numbers from 128 to 255, it would give each number a particular symbol. But just if you use that standard. Let's just look at it here. Yeah, so for example, there should be a table here. Here it is. Yeah. So for example, E, okay, yeah, I will donate to Wikimedia, but not right now. So for example, hex code D6 is the German umlaut Ö, the O with 2 funny dots on the top. And here you see how it's drawn. Thank you, Wikipedia, for how you draw an Ö. Yeah, so this is the, so as you see, it's all these Latin script special characters which cover most of the symbols you have in the European languages, right? Including German. So that's one way to do it. You just, for the upper part, and then you can switch that. So maybe you're now Cyrillic or Chinese or something, then you have a different character set there. And this you sometimes find you have it in Microsoft Word or in mail programs. They switch the encoding and say, now let's use this, now let's use that. But yeah, that's also not nice. You just have 128 different characters, and if you want to combine many of them, you have to switch all the time. So Unicode solution is very simple. You have one number for every symbol in the world, but this now has to be a large number potentially, right? Not every symbol in the world, but let's just say almost. And this is how you do it. So here's a number, capital small a. You just use a small number, 97 for capital A. And these happen to be the ASCII numbers. I have a slide on this. Now for the German umlaut, you use a slightly larger number. And here are the hex numbers, 228. And for some reason, this is here. And now some funny new symbols like the euro sign, they get even large numbers. And you can see here I wrote how many bytes do you need to write this. This is fine with 1 byte. Here you already need 2 bytes. Here you need 3 bytes. And Unicode knows slightly over 1 million different of these numbers. And each number corresponds to exactly one symbol. And we already, I'm sorry, I want to go here. We already saw this here. So for example, the smiling face with horns, not called a devil, has the number, where is it? This is the hex number up here, but there should be the decimal number, 128,520. So that's just a Unicode number for this, and it will never change. It will remain from now until the end of the universe, the Unicode symbol of this. So that's simple enough. Now you have a number for each symbol, and this number can become very large. 1 byte is not enough, 2 bytes is not enough, just 65,536. So how many? Up to 4 bytes it is. And now how do you represent that in a byte sequence? And now there are different ways. Of course, one way is to say, and that's the simplest one, 4 bytes are enough. With 4 bytes you can represent over 2 million numbers. Let's just always have 4 bytes per character. And there's a standard for this, and it's called UTF-32. Encode each character in exactly 4 bytes. That's simple, but very wasteful, right? Because for most characters you only need 1 byte. And so you also have a standard which uses 2 bytes for every character, which is often enough, except for very special characters where you need more, and then you use 4 bytes. This is what Java does. I think I have a slide on this, which is kind of the worst approach of all, because now it's still wasteful, but it's not always the same number. So I think this was a bad decision by the Java people, but anyway, history. And then there's UTF-8. That's what everybody uses for a long time now already. You just use as many bytes as you need, basically. So 1, 2, 3, or 4. And this encoding I will now explain. And now, of course, your encoding has to be such that you can see by just looking at the bytes, is this a 1, 2, 3, or 4 byte code? It's actually a very elegant and nice scheme, very easy to understand if somebody explains it to you, which I will do now. Yeah, so 32 is fixed size, just to say that again. Always 4 bytes, that's easy, you know, 4 bytes, 4 bytes, 4 bytes, but very wasteful. These are variable bytes, so you need a way to figure out, okay, how many bytes belong together to form a character. And here's the details of UTF-8. If you have a small number which you want to encode, for example, in the ASCII, right, you want to encode the capital W, which is 87. This fits in 7 bits. And then you just, the UTF-8 code just has a 0 at the front and then the 7 bits which encode the number. So most symbols, 1 byte. You encode it like this. If you have 2 bytes, which means your code point fits into 11 bits, then you just encode it like this. So you just reserve some bits here in each byte to say, what am I? So this says 110, by just looking at the byte at the first, 110 means I'm the first byte of a 2-byte UTF-8 sequence. And just the number of ones here tell you how many bytes. It's actually very elegant and very easy to understand. These bytes actually have content now, and 10 means this is a continuation byte of a UTF-8 code multi-byte sequence, right? So, and here I have the code point, and just you can easily see this is 16 bits minus 1, 2, 3, 4, 5 is 11. So you have 11 bits for contents. And it just goes on like this. So now if you need 3 bytes, then you just, the first byte starts with 1110. This is no contents, just signaling this is the first byte of a 3-byte UTF-8 character. And then come some bits carrying contents, and then I have 2 continuation bytes which start with 10. And you can easily compute yourself. 3 bytes have 24 minus 1, 2, 3, 4, 5, 6, 7, 8. 24 minus 8 is 16, and you can do the same with 4 bytes, and that's it. And here you can fit in 21 bits, and 21 bits is enough for 2 million, and there's only 1 million code points, so that's more than enough. That's why the standard only goes until 4 bytes. So just by, and now let's look at some nice properties, and then we are done. Many of the slides are just for reference. It's a really nice standard, UTF-8. There are some standards where you wonder what have these people done, but this is a great standard. So for one, as you can see here, if you have a small number, it's just a normal ASCII code, right? By definition. So this, if you just write the 87, the W, capital W, it's the same in UTF-8 and in ASCII. Which is great because it means that old code will not break if there are no special characters in them. If you have a sequence with only very normal standard characters, it will be a valid sequence in UTF-8 as well. So that's a good thing that they did that. Here's another nice thing I'm just telling. If you have the next more complex thing where you have a 1 at the top, which means you have 7 bits, then this is just the ISO 88591, which was previously the most frequent special encoding. Of course, a strong bias here towards where this came from. No, this is wrong what I just said. This is a 2-byte sequence. But the Unicode, it's mostly right what I said. Just one little side remark was wrong. Doesn't matter. This has so the ä, for example, let's take the German umlaut 228 in this ISO 88591, which I explained to you. It's E4. If you write this in binary, it's let me show you this one thing because a typical exam question, or at least part of an exam question. And you should absolutely know this as computer scientists. In case you didn't, now is the time to converting hex to binary. What is E4? I mean, below you have the result, but let's do this anyway. E4 in binary. Of course, one thing you could do, this is hexadecimal. You could first convert it to decimal. 4, then A is 10, right? So E is 14. You could multiply 14 times 16, right? I mean, this is, I hope it's correct, right? E is 14, yes? So this is 14 times 16 plus 4. What's 14 times 16? 224. I hope calculation in your head is, so it's 228 in decimal, and then I could convert the 228 to binary again. But you don't have to do that because hexadecimal, this is 4 bits and this is 4 bits, right? And this is, so that's 14, and 14 as a, so this is a 4-bit number. And let me just write that. So that's a 4-bit number and it's 14. So 14 is, you have an 1, 2, 4, 8, so you certainly have the 8 here. Then do I need the 4? Yes, I need the, what's in 14? 8, 2, and I guess that's 14, right? I have the 2, I have the 4, and I have the 8. I think that's correct. That's 14. And the 4 is, yeah, it's just I don't have the 1, I don't have the 2, I have the 4, and I don't have the 8. So there we go, right? So you just have to encode the individual. That's actually called a nibble, half a byte. I think it's called a nibble. I hope that's half a, yeah, And so now you get the binary sequence. So yeah, you can do that, but don't do that. Don't convert to decimal, do this computation, then back to binary. It takes you 3 minutes, whereas this is half a minute, very fast. So from binary to hex and vice versa is very easy. So E4 is 1110, 0100, and actually it's correct as we see below here. And as it happens, the Unicode code for these ISO characters, the code point is just exactly what it was in this old standard. It's on the slides here. And of course, UTF-8 is made such that only the rarely used characters then need, or the ones which came later. Like the euro sign was a bit late already, so it uses 3 bytes because it wasn't invented. And it's an invention of the new millennium. Yes, the smiley isn't aligned. And that's another thing. You can, that's one more thing, and then I think we should almost stop. Another nice thing of the encoding, look at it, and that's important in practice. You now have a sequence of bytes, and you are somewhere in the middle. And now you want to continue passing from there. You don't want to, I mean, inherently this is a left to right thing, right? If you go from the beginning left to right, you can decode it. But what if you are in the middle of a string? Well, just looking at 1 byte, you know what's going on, right? If it starts with 1, 0, then you know you are in the middle of a sequence. So either go a little bit to the left or to the right until these things you can always identify. They start with 1, 1, 1, 1, 1, or 1, 1, 1, or just with a 0. Then you know that you are at the beginning. So just by looking at 1 byte, you know exactly, am I at the beginning of a UTF-8 multi-byte character, in the middle, or, and then just by going a little bit to the left or right, you can continue passing. And it's always full integer number of bytes, either one. It's not that part of bytes encode characters or funny things like this. One more thing you should know, of course, for every Unicode, there's a valid UTF-8, there's a valid byte sequence, but not vice versa. So this is not valid UTF-8, so I'm using the template for a 2-byte system here, and now I have all zeros here and just 7 bits which are something else. And this is not valid because I could have encoded this in 1 byte as well, right? So there's some ambiguity here. I could use, if I have a short code point, I could also in principle encode it with 2 bytes, but that's just not correct. So if you would have a sequence like this, then any program processing it would say that's not valid. And it will be shown, this is a symbol, you don't see it so often anymore, but you used to, this says invalid UTF-8 characters. Okay, now I think we have to come to an end, but this is, yeah. So in the URL you can't have arbitrary characters, we already saw this, and you just use percent encoding. Right, the percent, and here comes the hex code of the number you want to encode. And you have to do it for the exercise sheet, but I think the slide is enough. We don't have to see it now. So if I send a space in the URL, it will be %20, and then you have to encode it. And the last part, I think I will show it in the next lecture in the new year. This is not something we have to do now. You can look at it on the slides. Let me quickly show you the exercise sheet. I think it's clear what you... So first, make it dynamic, what I did in the first part of the lecture. Take the security stuff to heart, which I explained to you. Make sure it doesn't happen. But we have some nice Easter eggs for you in the hidden in the data. Maybe you find them, maybe not. And you should combine it with the SQL to Sparkle stuff. This should actually Which point? Is it here? 2 or 3? It's 2, right? Yes. Anyway, it's explained on the sheet. It's basically just using what you have done. I'm sorry, we should now really finish. It's just using what you have done for the previous sheet and building it into your web app, which is just launching a Sparkle or SQL query for the entity which you are searching and just showing some triple. It's just to show you that that it can be easily combined all in one web app. So that's the exercise sheet. Is there any question for now? Last question in the old year in this lecture? Anything unclear for now? So I recommend to at least start this week, yes?
Just have a note on the slides it says lecture 8, but we're in lecture 9.
Where did it say lecture 8?
On the slides at the bottom,
Which slide?
all of the slides, all the way at the
Oh my. That's great. While I correct this, can think of another. Wow. Have to go to the slide master. 9. Now it's corrected. Thank you very much. Any other question for now about anything? Of course, there's the forum. Okay, so happy, nice, long, relaxing holidays, and see you next year in 4 weeks. Bye.